Hi there, I'm Clifford Bates, and welcome once again to kind of what this is basically basic political science research. This is a special series looking at the basics of doing research using Stephen Van Evera's book, A Guide to Methods for Political Science, as reading through it and kind of giving you understandings. So far, we've been looking at this is the fourth video, and we're still on the first chapter of it, which deals with the questions. We've been doing the general theories about theories, hypothesis, how you do it, what makes a good theory. Now, today, we're looking at testing. How do we testing them and the question of what's going on with them, right? He says, let's look at this. How can we test things? Now, how can theories be tested? Okay, this is Van Evera. We're looking at Van Evera basically 27 through page 40. Okay, this is question of testing and nature of testing. Right? How can we test? And he said we have two basic ways of testing theories: experimentation, observation. Okay, observation, and okay. Observational tests. Now that's these two. The observation tests have come in two varieties: large and in case studies. We have a universe of three basic testing methods: experimentation, observation using large n. And large mean large number case studies, analysis, which uses statistical, quantitative, statistical, and observations using case studies. Now, 29, this is like this. Deduction applies a fourth way to evaluate theories, and deduction of this, using deductions deduction. If you add deduction, right, deduction applies a fourth way to evaluate theories. Using deduction to evaluate the hypothesis of what A causes B, we would ask if A and B are examples of a more generalized phenomena, A and B, and that already known to cause each other. If so, we can deduce that since A causes B and A and B are examples of A and B, A must cause B, right? On deductive assessment of theory, e.g., Hempel's discussion of theoretical support for theories in his book, Philosophy of Natural Science, and his related discussions of the deductive normological explanations and covering laws on page 51 of the same work. The former are explanations that operate. Let's go do this. I'm going to flip around sometimes here, right? Um, the former are explanations that operate by deduction from general laws. The latter are general laws from which specific explanations are deducted, right? This is saying most common sense explanations are theories we accept because they are supported by deductions of this sort. However, a deductive evaluation is not a test of a theory, right? This is the point, that this is not a test. It's something that deductive, this is true, this is not testing. This is just, rather it applies to a previously tested law to a new situation. Observation research designs are also called quasi-experimental, right? In this regard. So therefore, this is why he doesn't include the deductive here as this. It's a way to evaluate theories, but it's not necessary. You don't test it. There's no real testing there in that sense. Testing, what do we mean by testing? Testing is basically a means to test something, whether something is valid or not valid, true or false, valid or not valid. Does it really reflect? Is what is being claimed valid or not valid? Okay, and we do this by different ways. Now, of course, he'll go on to these three ways, right? We talk about basically three ways we can test in this sense, not necessarily off analysis, but experimentation, large scale analysis, and case study, right? Experimentation. One, the investigator infers predictions from a theory. The investigator exposes only one or two equivalent groups to the stimulus. The results congruent or non-congruent. Okay, congruent means something that agrees, coalesces and agrees, and separates from it with the predictions. Are the results congruent? do the results come together and form a clear pattern, or do they just spread all over the place? The congruence of prediction and results collaborate in theory. Incongruence, infirms, it means falsifies it, right? Okay, this is the problem with experimentation. In social science, it's very hard to do experiment. In fact, it's unethical. We have the ethics tests on this. There's a lot of ethics tests because dealing with human things, politics. What is the? In fact, the great experiments like the Stanford prison study and things like this, when years later they were returned to, they discovered that the findings of these things weren't real because often the activists were understood that it was not a real situation, and instead of really doing behavior that they normally would do, that they engaged in behavior that was kind of more excessive and more extreme, knowing that, like, torturing of people. There were the torturing, the idea that I'm making this thing, I'm doing this, I'm torturing people. Well, in role, this is like, think about this. Video kids playing video games, right? Um, Most kids aren't going to aren't going to go up and hijack a car and kill people and run people over as they playing what do you call Grand Theft Auto, right? Playing a game of Grand Theft Auto, a video game that's violent, you're going to be doing things that you don't really do in reality because there's no real consequences in it, right? But once there's real consequences and real effects, people's behavior is different. And that's the problem with experiments in the social sciences. One, an experiment tends not to be the real thing you're dealing with. This is why a lot of times we look at, people's participate. No, people who study participation will look at student government and think at these student governments to explain why what works and what doesn't. But then when you look at it, well, wait a minute. The incentive, the actual power involved in student government and the effects of it is not the same as in a real legislature. So you don't get the same kind of people. You don't get this. In other words, the people who enter in it for completely different reasons, and therefore you get these phenomena. It is not a true experiment or something representative that could therefore be used as a kind of proxy to understand something. So, like the Stanford, the famous prison experiment was shown in the early thousands or late 90s and thousands, were very much criticized, and it's argued that the experiment distorted the reality. Now, in my class, I talk about in fact, actually the real studying of the actual observational experimentation, observational behavior of the German guards really in the Holocaust, in the way the Germans actually had to deal with that. Even even the story of the Eisengruppen of the units show that there were limits to what you can get out of that. That really ran counter to much of the Stanford prison literature. Okay, so yes, but wait a minute, you're saying the real Nazis were not as Not, and I'm not saying that. I'm saying that there was limits to what could be done. Which the that human nature and human psychosis people, there were certain limits that could not be overcome. Now you could stretch them and you can push them and you can bypass them and fight around it, but they weren't as malleable and shapeable and social malleable as the Stanford study indicated. That's why it was, that's why observation is usually stronger in social science. In social science, we tend to do under observation. We look at observation. Observation. An investigator infers predictions from a theory. The investigator passively observes the data without imposing an external stimulus and a situation and asks for observations that are congruent with the predictions. Now, observation research designs are also called quasi-experimental. People say, right? Oh, it's not really experiment, quasi-experimental. There's kind of an argument that there's no control. Experiments always have a control mechanism, right? that we do this is the medical experiments. There's always a control. You have a group that a subject to do it, and then you have the group who doesn't do it, right? And therefore we test experiments often have consumption control. Um, Observation, it's hard to get the standard of control, right? So therefore this is why they people don't really think. There's kind of in hard sciences there's they prefer experimentation, but a lot of stuff is observational too. I mean, what you gauge in the experimental science is observations of what happened too. That, I mean, particularly, something was done, yeah, but then you observe the thing to do things. Now he says prediction frames observations we expect to make if our theory is valid. Right, the prediction frames observations we expect to make if our theory is valid. They define expectations about the incidents, sequence, and locations, and the structure of phenomena. Now, this is very known. I use prediction to define expectations about the occurrence of phenomena in both. Okay, returning. We had an interruption for a second. He says, I use prediction to define expectations from the occurrence of phenomena in both past and present, from both the past and future, if a theory is valid. Others call these expectations the observable implications or test implications of a theory. This is Cohen and Verba, Designing Social Inquiry, and others. Hempel, in his books, likewise. Still others use post-diction to refer to expectations of what historical record will reveal, reserving prediction for things about the future. We use predictions to design tests for hypotheses, but predictions are also hypotheses themselves. They frame phenomena that the independent variable should cause if the hypothesis operates. Pardon. Cause if the hypothesis operates. These phenomena include observable. Okay, I apologize. I just had a sneezing fit that's really bad. In other words, that in other words, these tests are kind of hypotheses. They frame phenomena that the independent variable should cause on the hypothesis. If the hypothesis operates, it works, right? It works. These phenomena include observable effects of the dependent variable or intervening variable, and the effects that these variables produce. Thus, the distinction between a prediction and a hypothesis lies not in their nature, but the use to which they are put. So, therefore, they're the same thing. And the difference is, again, what is there being done here? A prediction and a hypothesis. In other words, a prediction is what is the he says not their nature is the same thing. I'm going to make a claim and to see whether it works. And a prediction assumes that this is going to happen. A hypothesis likewise assumes something's going to happen. In other words, the distinction between them is not in their nature, but how they're being used in this sense. So again, they define the question of this relationship between here, right? And he basically wants to say predict. Now, there's a whole discussion. He's using prediction both in terms and using prediction rather than more technical, like he said here that these are observable implications and test implications. Well, no, that's a prediction. In other words, you're making a claim. In other words, he Venevra prefers the simple term, and not and this is prediction is for the future and post-diction. No, that's just a neologism. So Venevra says keep it. I think in many ways Venevra is the master of KISS, the principle KISS. Keep it simple, stupid. Okay, don't make it too complicated. Don't get too jargon heavy. This is why I like Venevra, because he gets rid of jargon. He simplifies the theories, these approaches and methods in a clear, concise way that works. Okay, so let's continue. Of the question of observation. For instance, we can always predict the values on the independent variable of valid theories. We can always predict that values on the independent variables of Now, theories should convey over space and time, other things being equal. In other words, convey means they come together, they'll pattern, right? They will have a certain direct pattern. They'll agree. They'll have a discernible, clear pattern over space and time, right? The values on intervening variables that form the theory's explanation should also convey with the independent variable across space and time, right? Variance on the independent variable, now this is featuring over here, should precede in time related should precede in time related variance on the dependent variable. Okay, in other words, this is a guy. This is interesting in that sense. He's saying what here? Now let's go over here to what he said. Variance on the independent variable should precede in time related to the dependent variable. If a social theory is being tested, actors should speak and act in a manner fitting the theory's logic. For example, commercial competition causes war. Elites deciding for war should voice commercial concerns as reasons for law, right? They should behave as what the theory. In other words, if we're testing a theory, actors should speak and act in a manner fitting the theory. Right? There has to be connection. Have to be. In other words, you're saying they're doing this. What they say or do must fit the definition of what you claim they're doing. Right? Some hard scientists, chemistry, biology, physics, rely largely on experiments. Others, astronomy, geology, paleontology, rely largely on observation. In political science, experiments are seldom feasible. In other words, with rare exceptions such as conflict simulations of psychological experimentations. Right, but this is very true. In psychological, but the problem with this again, conflict simulations again they become LARP. We have the problem with LARP in simulations. The problem with simulations and even psychological experiment becomes the problem of LARPing. Live action role playing. In other words, LARPing, where people go to, in other words, because they know it's not real, therefore, like the kids playing the video game, they'll do things that they would not do, okay? Because they don't think that they know that the consequences on. Of course, they're told they put the play, but no one behaves in a role playing game really the way they behave in life. Okay, same thing with video games and something like this. They know that okay, the consequence is not going to be the same. They are not going to die, right? Most people are, the war game, games of war where they're playing. I mean, people do stupid things. Yes, they try not to get themselves. They do that, but they still engage far more risk and engage in far more risk than people normally do. So, in fact, this is one of the things why they not. By the way, that's one of the reasons why the military likes this, because what it does is you get by playing the game, you habituate yourself to doing that behavior. Okay, you start habituating yourself to take the risks, and that's what sometimes, in other words, this is why in military they do similar conflicts. They do game things in live war games and do things because they start taking risks, and therefore you get into the habits of doing therefore in training you get into the habits of doing things that are very risky, because the cost that it's habit now, and that's what and that's why it's not, in other words, they do it not because they're trying to see how things life in real life. No, they know that this is not how real life works. In fact, if they took people and put it in real life, they're not going to get the same actions. You would not. You have to habituate them to do it. This is why we talk about this. This is why social science and political science rarely does it. This leaves observation as our prime testing method. Now, the two types of observation analysis are possible. It's two types. Large N, or statistical analysis. Now, 32, right? This is primers on large N numbers is Babby's practice of social research, Shively's craft of political research, planning on analysis of observation, Boland's how to design, analyze, and write doctoral master's research, Edward Tuft's data analysis for policy and G.D. Reeves' essential statistics, Sendor and Cochrane's statistical methods, and David Friedman's statistics. And this is what, I mean, I'll tell you, this will happen. honestly, I wish my teacher at undergraduate level gave us this before. Instead, normally what happens is you get dumped in large N statistics. And one of the problems with large N statistics and statistical models is most people, it's you got math phobia. The biggest problem is math phobia. You get statistical methods. Most people don't really, and by the way, most political science teachers aren't really complete method teachers, aren't really that knowledgeable to explain concepts of math in a way most people can understand them. In fact, math teachers are very rare. Good math teachers. My own experience of this was in high school between two math teachers, Mr. Osterman and Mr. Lepore. I mean, teaching algebra, it was different. Mr. Osterman was a nightmare. I didn't think he was. I got nothing, and maybe he just didn't like me. We didn't get along. I have no idea, but I was. It was an ultimate nightmare to a degree of almost having to go to going to summer school to be able to do it, and having the summer school with Mr. Osterman again. So it was a complete nightmare. And then with Algebra 2, I went from barely passing to getting A's, not because the teacher was easy. Lepore was Mr. Lepore was known as a tough case. He wasn't easy, but it was. I thought for me, he explained things better, and he was more reasonable in explaining things, and I understood what he explained and elaborated things in a way that I understood. And this is what's problem with mathematics. And a lot of, I mean, even I would say my teacher, Mr. Dr. Hyde at undergraduate, he was, he knew how to do it, but did he know how to explain it to class? Often the textbooks are very just pure mathematical, and you need someone to actually explain these things. And also, the problem here is not the methods. The methods don't get us this. We have to have this actually knowing this stuff has to happen before you do the methods. Because what the methods are only doing is showing you, it's statistical methods. You'd have to know what the meaning of congruence or not congruence is. This is understand that. Well, why do you have congruence? Why do we have of regression effects or correlation regressions and chi-squares and all these statistical tests of showing what degrees of what probability correlation, right? Correlation coefficients, correlations, degrees of correlations. All this is kind of mechanisms of doing this. But the statistics is not the only thing of large N. Large N means large case number. You're doing a lot of case numbers. Okay, this is statistical analysis. A large number of cases, usually several dozens or more, maybe even thousands, right? In the medical sciences, is millions, right? Is assembled and explored to see if the variation conveys and the theories can predict, right? So therefore, we find statistics, we use statistical tools to find covariance and whether there is a covariance, that's correlation, right? And the degrees of correlation and covariance and interconnection and possibilities and patterns of behavior. There's mathematical numbers, and then we have plot scales, right? We have graphs. We do XY graphs of this so that we see mechanisms of now it's two case studies. The case study analysis. The analyst explores a small number of cases, as few as one, in detail, to see whether events unfold in the manner predicted, and if the subject involves human behavior, whether the actor speaks and acts as the theory predicts. Right. Landmark writings in the case study methods. See note 1 to chapter. Chapter 2. Right. That's note 1 to chapter 2. It says right. Which method, experimental, large N, or case study is best? Which one is best? We should favor the method that allows the strongest test. So therefore, the question is which of these tests? The one that allows the strongest test. I discuss strong tests later in this chapter. More tests, the better. So therefore, in other words, things that allow us to test. Now, remember, what does test mean? Test means something we're testing to see if the claim being made is valid or invalid. Does it? That's what it is. The truthfulness, where it's truth. This is Socratic. We get this. This is the famous whole point about Socrates. This is the whole base of knowledge. Remember, all knowledge begins. This is from Socrates from the beginning. The Socratic position of this is that all knowledge begins with opinion, belief. Right? We believe something. It's what is a belief? Hypothesis. It's our opinions, our beliefs, our belief world. We have an opinion. We make a claim. We make a belief. This is we infer something. We think something is true. We think it's true. We believe it's true. We hold it. We may even hold it to be true. But do we know it's true? No. We only know it's true whether we have tested it, or whether either through experience or confrontation with the thing. We validate whether it is the thing we believe valid or invalid, true or false. And that's the distinction between belief and knowledge. Knowledge moves us away from belief, from the belief that we hold something, hypothesis, to knowing something, whether something is, and knowledge is knowing whether, it's not necessarily knowing something is valid, it's also knowing something that's invalid. This is why knowledge, in other words, finding that we're wrong about something is as much knowledge as finding that we're right about something. And this is why a lot of science journals and research journals, published items prefer to privilege the positive and doesn't really want to talk about the negative results, unless it's the negative results is destroying some big important, you're tearing someone apart, you're tearing someone that we've always thought, and you've showing how they really got it wrong for the reasons why they got it wrong. Okay, that may get published because it's taking something we all believed that was to be true, and now you're showing it not to be true. But most research is going to basically discover, and most real research often fails, and it doesn't prove what you think it's going to prove. But you discover things, you discover new knowledge. Knowledge is discerning, knowing what is valid and what's invalid, what is true, what is false. Now, once you've known this and understand this, now you have to go read back, recalculate your understanding, and then reapply to see if what you now learned is repeatable. Does it really conform to this reality? So that's one thing. So that's what tests mean. We should favor methods that allow for the most strong tests. More tests, the better. More tests are better than fewer. So more tests are better than fewer. What is it? Strong tests better than weak. Many strong tests are best, as are methods that allow for strong tests. So therefore, the methods we pick should be tied to help us to get to the best tests. Therefore, like he says, we have an analogy here, right? More tests are better than few. Strong tests are better than weak. Many strong tests are best, and as our methods, the methods that allow those strong tests or those more tests, right? The structure of available data decides which method is strongest for strongest for testing a given theory. So therefore, in other words, the kind of evidence you got will determine the kind of test you can make. This is why statistics may not be good. That again, this is the problem. One of the things I took a stats course at grad school. I sat in on it. I didn't really take it because I wasn't. I just sat in and I heard this. The guy who was teaching statistics at doctoral program was very liked, Dr. Gordon. He was a British guy. He was kind of funny. He was very cynical. He was very hostile to political science, by the way. Even though he was a teacher in political science department, he was skeptical of the use by most people of political scientists using statistics. And that was funny because he and the Americanists who were the champions of this were, it was kind of funny seeing, if you listen to Gordon, he was very critical of the advocates of. I mean, they were friends, and they were kind of in the teaching the same. He was teaching them. He was the real knowledgeable person doing the statistics. They were the practitioners. And his critique, and I remember this like this, that a lot of the data is not suitable for statistical tools. A lot of the phenomena we observe aren't really easily convertible to things that can be used in regression and other statistical tools. We can do it, we can force it, we can create the art, but that in doing that, is that real? Is that thing real? And I said, is that really? And he also made the point that most of the statistical modeling tools had, particularly regression, had requirements that that the data you use had to have a certain characteristics. I usually, it had to be ordinal, linear, continual. What was it? I forget it was ordinal, integral, linear, and continual. Ordinal means it has to be numbers, right? Linear must have a single line. That there's no other, it's not it's linear data at each point. Integral meant that the space between 1 and 2 was the same as the space of 3 and 4, and that the space between 2 and 3 was the same as 1 and 2 and 3 and 4. In other words, all the spaces between that were the same degree, and then continual goes on, right? Okay, think of political parties. Are the space between each political party integral to each other? And how do you order them? They're ordinal, but what is the ordering of the parties? Right? This is not. And binary concepts, things that a piece of data that's binary, like sex or marriage status. Okay, you say about road divorce, or you're single or married, right? But then say about widowed, dun. Okay, but widows is another form of single, right? Even though there might be differences of that, but binary numbers, binary things is not continue. In other words, these things are not. It's problematic to use them in statistical equations because they're not really the same kind of data in that sense. You can do it, and sometimes you'll get results that do reflect the reality we're observing. So the pure statistician has problems with it, but the question of this, does it work or doesn't work? If it does work and it reflects, but the pure theorist say no, but you're forcing the data, and therefore that's not correct. Okay, well that is the problem here. This is why the thing we always must understand. Like this is the problem. Sometimes we have too many people have a statistical tool, and they use it for everything. Well, like another tool, like another method or tool, like game theory. In game theory, prison dilemma. They have prison dilemma. It's a wonderful. It's a tool. It is a game, a specific game. Okay, the classic game prison dilemma. Well, is every social interaction a prison dilemma? No. But if you have the problem was with a lot of qualitative political and social sciences is they have a tool, and because they have this tool, it's like a hammer, right? It's a hammer. So therefore, everything looks like a nail, right? Everything looks like it's suitable to the hammer. Everything is becomes suitable to the method. No, methods should never determine data, the kind of data. The data type of data you have should determine the methods, and that's the problem here. So, the structure of the variable data decides which method is strongest for a given theory. Most theories of war are best tested by case study methods because the international historical record of pre-war politics and diplomacy, which serves as our data, usually tends to lend itself better to deep studies of a few cases than the exploration of many cases. A few cases are detailed in great depth, the two world wars, but the historic record deteriorates sharply as we move beyond the 15th or 12th beyond the 15th or 20th century. No, no, beyond, sorry, as we move beyond the 15th or 20th case, right? As a result, case studies case study often allows more and stronger tests than large N methods. In other words, in other words, large and this about studies of war. Case studies win not because there's not enough data to allow strong tests and large R methods. But case studies give you stronger tests than large N methods allow. Conversely, large N methods are relatively more effective in testing theories of American electoral politics because a very large number of cases of elections or interviewed voters are well recorded. So therefore, you have lots of data. The data is there; it works, and therefore, the kind of data you got here, allows you to do this. Case studies can be strong tools for exploring American politics. However, especially if in-depth case studies yield important data that otherwise is inaccessible. Examples of Richard Fernando Homestyle, right, and the House methods and their districts, right, or Fiona Congress. This is Congress. Congress is a very good, and the U.S. Congress. This research of the '70s, early '70s, and maybe the mid '80s, both Fenno and Fiona. In Congress, I teach Congress at my school at American Studies at Warsaw University. So, semi-regularly. I mean, less and less now because students aren't interested. It is technical. Is you have to look at case studies, and case studies are the best method of doing this. But okay, so therefore you have this that when yields important data that is otherwise inaccessible. Case studies, right? And large N analysis can be a strong method for exploring international politics if relative test data is recorded for many cases. Right? See, for example, the many good and large N case of democratic peace theory, right? This is 35. Footnotes, for example, Chin's Mirror, Mirror on the Wall, are freer countries more Pacific, right? This is a 1984 thing. Or Adric Weed's Democracy and War Involvement, right? And Mao and Russet's Normative Structural Causes of Democratic Peace. A discussion of strong tests include Ecclestein's case study and theory, and discussed in the terms he called crucial case studies. Oh, that's 36. Sorry. I'm stopping here. I should have stopped here. Oops. They're talking about Mao and the APSR piece of 1993. Okay. In other words, experiments is the least valuable approach because experiments are seldom feasible in political science. This is the great line. That experiments are least valuable because it's seldom feasible in our political science. Now we turn to strong tests, weak tests, predictions, and tests. Strong tests are preferred because they convey more information and carry more weight than weak tests. Right? This is now 36. Discussions on strong tests include Ecclestein's case and theory, discussing the term he called crucial case studies. His term for cases supporting strong tests. And another book is Arthur Schoenkam's Constructing Social Theories, right? These are kind of suggestions of these things, right? This is why we do strong tests. We should have strong tests because they convey more information. They give us more information and carry more weight than weak tests, right? So therefore, again, I apologize for the handwriting, right? But this is some notes because of the addition I've been doing. A strong test is one whose outcome is unlikely to result from any factor except the operation or failure of the theory. So a strong test is no other fact. A strong test is what? A test that produces that no other effect can be the result expect. In other words, are the result from no other factor except the operation of or failure of the theory. Strong tests evaluate predictions that are certain and unique. A strong test is strong. It has to uh, 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 um, nothing but, in other words, that strong test whose outcome is unlikely to result from any other factor, right? That's one aspect of it. Say, but this is defining it. That there are predictions, they evaluate predictions that are certain and unique. A certain prediction is an unequivocal forecast, unequivocal, leaving no doubt. In other words, unequivocal forecast. There was no doubt. The more certain the prediction, the stronger the test. The most certain predictions are deterministic forecasts of outcome that must inexorably, that's impossible to prevent, occur if the theory is valid. So therefore, a deterministic conception, the most certain are deterministic, that this must happen. It's either or. It happens or it doesn't. Okay? Probabilistic is different. Deterministic and probabilistic, go back to this. A deterministic one is that there's no choice. It's inevitable. It's either this or that. Probabilistic is, well, it may happen by a certain degree. That this tends to happen at this ratio, this percentage likelihood. Or this tends not to happen at this percentage unlikelihood, right? How odds, right? The odds, right? The percentage of the odds, right? How, the more certain the more certain the prediction, the stronger the test. He says that this again back here, and that therefore deterministic forecasts of outcomes that must inexorably occur if the theory is valid. If the prediction fails, the theory fails. So if it fails, the theory has failed. Since failure can arise only from the theory's non-operation, right? So this is if you're deterministic. A deterministic thing, the theory fails if the test shows if you're dealing with a deterministic thing, right? A certain test that's very certain, and if it fails, if it passes, it passes. If it fails, it fails. Either or, right? A unique prediction is a forecast not made by other known theories. Now, the unique is this. This is the reason why it's unique. Uniqueness, right? A prediction is a forecast not made. That is, this is causing it, not something else, right? The more unique the prediction, the stronger the test. So, again, the most unique predictions forecasts outcomes that could have no plausible cause except the theory's action. In other words, nothing but this could produce it. If the prediction succeeds, the theory is collaborated. No, collaborated because because the other explanation for the test outcomes are few or implausible. Right? That's the strong. That's the most. That is that this is high. The most unique predictions forecasts have. In other words, if it has only this and nothing else, this is very highly, and therefore, if it gets it, there's no other alternative that answers it. Right? In other words, the other explanations for the test outcome are few and implausible, right? Certainty and uniqueness are both matters of degree, right? This is important to understand this. That this is both matters of degree. Predictions fall between on a scale from zero to perfect, both on both dimensions. This is like that the complete no certainty to complete certainty, right? From no uniqueness to complete uniqueness. It's a scale. So we have high. In other words, you have this scale, but then we have a divide between high versus low, right? High versus low. Predictions fall anywhere in the scale between zero and perfect. He says texts of predictions that are highly certain and highly unique are the strongest, since they provide decisive positive and negative tests. Right. This is strongs that are highly certain and highly unique are the strongest because they're both they're decisive in the positive and negative evidence. Right. They provide decisive positive and negative evidence. So As the degrees of certitude or uniqueness falls, the strength of the test also falls. So therefore, this is the highest. Now, tests of predictions that have little certitude or uniqueness are the weakness and are worthless if the test predictions has no certitude or uniqueness. In other words, a test of predictions that have little certitude or uniqueness are the weakest and are worthless if the test of predictions has no certitude or uniqueness. So therefore, they're the least. They're worthless in that sense. So why do we talk about a worthless test? Well, we have to understand that's a test that does this. This test is worthless. Now, are worthless tests always useless? Well, it's useless for validating or invalidating, but it might not be useless to coming up with ideas. And we'll see about this. We'll talk about this later. We can distinguish four types of tests. And therefore, remember, certitude, uniqueness, high, and low, right? Certitude, uniqueness, high, low. So therefore, 1, 2, 3, 4 categories, right? We can distinguish four types of tests, differing by their combination of their strengths. So this is uniqueness scale. Something's unique and certain. High and low. That's what, and then therefore every one of these is one type, or dun 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 dun, and therefore you get four varieties here, right? We can distinguish four types of tests, right? Differing by their combination and their strength. Now he's saying the types of tests, and not tests, the tests themselves. Now, individual tests will be one of these. Any test you create that tests the validity of a claim. We have to. This is what kind of test is it? Is it this? And now he's not going to do it orderly. I think. Remember, something that is both highly decisive and highly predictive. In other words, let's go back to unique, decisive, certain and unique. Sorry, certain. If something highly certain and highly unique, this is both. This is strong. This is the double. This is the strongest one, right? As in other words, that these are the strongest. Highly certain, highly unique are the strongest, and they provide the decisive negatives, right? And the one who does nothing, that's the weakest. So we have the highest weakest. But then we have other types that are low in one category and high in the other, and vice versa, right? So let's do the four types of tests during their combinations of strengths and weaknesses. The first two are kind of, let's do it, hoop test. Predictions of high certitude and no uniqueness provide decisive negative tests. So the hoop test is a case where the predictions of a high certitude, the predictions have a high certitude, but low to no uniqueness, right? This provides a decisive negative test. A flunk test kills a theory or explanation, but a pass test gives little support for it. Example of this is, the famous, the testing the null hypothesis. In social, we always test the null hypothesis. We do that first. Why? Just see whether the theory is plausible. Because if the null hypothesis passes, then the theory cannot be valid. But if it fails, okay, doesn't prove it. It only, in other words, it shows that the claim you're making may be positive, right? So that you have to have a pass here. But a OOP test is a negative test. If it fails, in other words, a flunk test kills a theory, right? A flunk test kills a theory or an explanation, but a pass test gives little support for it. So it eliminates. This is elimination. For example, was the accused in the state of the day of the murder? If not, he's innocent. Well, there's others. Maybe he had someone else kill him. But the question is, we know that he was not at the state of the murder, so he could not have done it, right? If not, he is innocent. But showing that he was in town does not prove that he's guilty, right? In other words, this is the kind of thing, it's a negative test. To remain viable, the theory must jump through the hoop this test presents. But passage of the test still leaves the theory in limbo, right? So the hoop tests are very useful because they eliminate alternatives. And remember, this is the famous thing in Sherlock Holmes, right? How does Sherlock Holmes find the guilty? Well, he eliminates of the possible parties. He starts eliminating those who could not be it, right? Eliminate the not relevant, and what remains must be the answer, right? What is that line from Holmes? Yeah, I have to find that line. Eliminate the alternatives, and then the one that survived, that which remains, is the answer, right? That's the kind of this is the deductive method, right? The deductive method in that sense. Um, in that sense, that once you eliminate that, you eliminate the things, and you get that. So therefore, you can do a lot of hoop tests that then eliminate the alternative, the different hoop tests to eliminate the alternative to find what the most plausible explanation is. Okay, so if that's the hoop test is a negative, it kills things, right? What about the smoking gun? Next to the smoking gun. Predictions. Smoking gun test. Predictions of high uniqueness and no certitude provide decisive positive tests. Passive strongly corroborates the explanation, but a flunk infirms it very little. So what does it say? If it passes, you're guilty, right? You're it. It's true, valid. But if you fail, it doesn't prove anything, right? For example, a smoking gun seen in the suspect's hand moments after the shooting is quite convincing proof of guilt. But a suspect not seen with a smoking gun is not proven innocent. Also, this is what a lot of forensic evidence is this, right? A lot of forensic evidence or video evidence or things like this, witness testimony about this is a kind of smoking gun. I saw you there. I saw you did it. Or this evidence leads that you were there at the time, the crime, right? And therefore, forensic, in other words, forensic evidence used either as a smoking gun. You're there at that time. You're at the scene of the crime at that time it happened. That is, whereas if you're not there at the time it happened, it becomes that same method has at one lay it can both be a smoking gun and at the same time a hoop test, right? I wasn't there, so okay, there's no that isn't me. Um, a smoking gun that is not you doesn't prove that you didn't do it, right? Okay, but the hoop showing that you could not have been there at that time does show that you could not that you're not there at that time. Well, that's you failed the hoop test, right? So therefore, this is the different mechanisms of how this works, right? An explanation passing a smoking gun test is a sort of strongly collaborated, but casts little doubt. Little doubt is cast on an explanation that fails it. So therefore, you pass it. It's strongly it's your highly collaborated evidence. But if it fails it, it doesn't it casts little doubt on the explanation. Right now, double decisive tests, predictions of high uniqueness and high certitude, provide tests that are both decisive in both ways. Passage strongly collaborates an explanation. A flunk kills it. So therefore, double decisive, very high uniqueness, high certitude. If I pass the test, it validates. If I fail at this, the theory is killed. Right? It kills it. A flunk test kills it. A passage collaborates. A passage strongly collaborates. Right? If a bank security camera records the faces of the robbers, its film is decisive in both ways. It it proves suspects guilty or innocent. Such a test combines a hoop test and a smoking gun test in a single study. Such tests convey the most information. One test settles the matter, but are rare. Such tests convey the most information. one test. But these are rare. Double decisive tests are very rare. It's very difficult to create something that is both double decisive. Okay, so therefore you have to have. So that's why you may have to do multiple tests. If you can get a double decisive test, then you don't need any other tests in that sense. But the rule is stronger tests, the strongest test, and more tests are better, right? So the more strong, as many strong tests, many tests. Okay. Now, last but not least, straw in the wind. Most predictions have low uniqueness and low certitude, and hence provide tests that are indecisive both ways. Passed and flunked tests are both straws in the wind, right? The metaphor, right? And actually, these are the most common, honestly, too. Such tests, and by the way, these are the most common. This is the problem, most common problem test. Such tests can result in the total balance. In other words, such tests can weigh in the total balance of evidence, but are themselves indecisive. Thus, many explanations for historical events make probabilistic predictions, right? Thus, in many explanations for historical events make probabilistic events. If Hitler ordered the Holocaust, we should probably find some written record of this order, right? This is 37. This is famous. In fact, there were no written records of an order from Hitler mandating the Holocaust, yet historians agree that Hitler did order it. Discussion is Sapien Hafner's The Meaning of Hitler, right? I mean, in other words, if Hitler, we should do this, whose failure may simply reflect the downside probabilities. In other words, whose failure may simply reflect the downside probability. We learn something by testing such straw man in the wind predictions, but such tests are never decisive by themselves, right? And hence, the last of four terms, hoop test, smoking gun, and double decisive test and straw in the wind, are my effort to fill gaps in the lexicon, right? This is his understanding of these terms. So therefore, they still fill in gaps, not decisive in themselves. But they're not never decisive. They may fill gaps of our things and get us to thinking about something, and they might help us generate ideas and theories or hypotheses, but they're not useful for. It's not decisive to validate or invalidate, right? Interpretive disputes, and unfortunately, this describes the predictions we usually work with. Right, this is the thing. Interpretive disputes often arise from disputes over what outcomes theories predict. Right, this is that. In other words, interpretive disputes, arise from disputes over what outcomes theories predict. Does realism make predictions that were contradicted by the end of the Cold War? Some scholars say yes, others say no. Such disagreement can be narrowed if theories are clearly framed to begin with. Since vague theoretical statements leave more room for divergent predictions, and if test predictions are explained or justified. In other words, again, this is the famous Cold War. Given that how the Cold War ended, does this prove that realism is wrong? No, it's that the conditions differ. In other words, realism and this are different sets of conditions. I think this is the big fight between realism and in IR theory. See, IR theory is always more pragmatic towards. In other words, if the conditions don't do it, in other words, IR makes sense in a situation of a certain world, but in a different other set of conditions that don't fit it, and that there's other situations are involved. But even the argument of neoliberalism had a failure. This is written in the 1990s, right during the height of the neoliberal optimism, right? Oh my God, everything realism is dead, right? Realism was kind of mocked and kind of perceived as dying, right? But then after 2008, all of a sudden, oops, things started falling apart, right? Even as early 2004, 2005, the realists were criticizing a lot of neoliberal international relations models, right? They always criticizing, but people were still believing the neoliberal model. But then all of a sudden, after 2008, the real cracks in the neoliberal model happened. And the question is this really one? This is that the theory results. In other words, this is the point he's making. Interpretive theories rise from disputes over outcomes of what theories predict, right? Such disagreements can be narrowed if theories are clearly framed, he says, and if tested predictions are explained and justified. Interpretive disputes also arise from quarrels over the uniqueness and certitude of predictions, right? So, in other words, so one interpretive thing about whether our definitions, right, whether the things is our theories clearly framed to begin with, and if their test predictions are explained and justified. In other words, this is one way. The second way is interpretive disputes raised from what? That disputes over the uniqueness and certitude of predictions. Is the prediction unique? That is, do other theories or other explanations predict the same results? If so, a theory test is less impressive, right? And if other theories can do it, like in the Fisher School of Historians argues that December 8, 1912, the war council, a sinister meeting between Kaiser William II and his military leaders, uncovered only in 1960, signaled a plot among the German elite to instigate a major war. On the war council, see Emmanuel Geis, German Foreign Policy, 1781 to 1914. Good friendly surveys of the Fisher School argument are a bid, that plus John Moore's Politics of Illusion. And more critical is John L. Langdon, July 1914, A Long Debate, right? This is World War I argument, right? Some critics answer that the Kaiser's mercurial personality explains his bellicose talk at that meetings. He often blew off steam by saying things he did not mean. In short, they point to a competing explanation for events that some Fisherites claim was a smoking gun for their elite plot theory of the war. The question then rides on the plausibility of this competing explanation. So therefore, in other words, we have a debate about this question. The Fisher School argues, oh, we found this smoking gun that proves that there's a plot. Well, wait a minute, but those of us that don't know Kaiser William, they knew he talked like that and blew off steams and that changed his mind. So that kind of throws a question into the uniqueness of and that this is being as certain as you claim it is, right? This is what is it? Remember what is a smoking gun is a high uniqueness and no certitude. So it's not as unique. In other words, this anger outburst was not unique in Kaiser William. So there's no uniqueness of this. This is very much typical of Kaiser William. So this is not a unique, and therefore this blows off the question. It becomes a straw in the wind at this point. In other words, you already have low certitude now. This is no longer, it's not highly unique, but not unique. And therefore, what was a smoking gun now becomes a straw in the wind because there's a competing theory about this, right? The question rides on the plausibility of the competing evidence. Is the prediction certain? In other words, is it unequivocal? In other words, the certain implies unequivocal, no other thing but this. If not, flunk tests are less damning. Okay. Some historians argue that the Spanish-American War of 1898 arose from a conspiracy of empire-seeking U.S. leaders who hoped to seize the Philippines from Spain. The absence of any mention of such a conspiracy in these leaders' diaries and private letters or in the official archives convince others that there was none. In this view, the conspiracy theory predicts with high certitude that means a conspiracy should be found. In other words, in the view of conspiracy, in this view, the conspiracy theory predicts with high certainty that mentions of a conspiracy should be found in these records. Conspiracy theorist answers that good conspirators hide their conspiracies, often leaving no record. The conspiracy theory is alive, they argue, because the theory predicts only weekly that conspirators should record their conspiracy. Hence, the lack of such record is a mere straw man in the wind, a mere straw in the wind that affirms the theory's own weakness. The question hinges not on the evidence, but on divergent estimates of certitude of the theory's predictions that a conspiracy would leave a visible record. So therefore, the question then becomes not about the theory, but on the evidence. The question hinges not on the evidence, but on the divergence estimates of whether there would be record. In other words, this is the famous thing. Someone, anytime conspiracy, this is my argument, conspiracies never really happen. Why? Because successful conspiracies require too few people, and big events require many people. So, this is why no one really seriously believes that the moon landing is fake, because too many people are involved, and there's no way, given there's no way that many people would hide such a secret. Even the Manhattan Project, secret project, were leaked out simply because that someone is going to break the secret and tell us, right? The Russians knew about it. Okay, they knew about it. They maybe know exactly. Maybe the spies, they'll get through their agents some more information, but they knew about it. Even great secrets. Even this is the thing. Secrets are never hard. Secrets in large scale organizations are never really secret. This is why conspiracies often fail. That's why they're rare in a sense. And successful conspiracies often require very few people involved. And therefore, it's very, and mass scale organizational actions that require mass people can't be really conspiracies, right? This discussion highlights the need to discuss the uniqueness and certitude of tests and predictions when interpreting evidence. So therefore, we have to look at the question. We're interpreting evidence. We have to address and discuss the need to discuss the uniqueness and certitude of the test predictions. All evidence is not equal because the predictions they test are not equally certain or unique. So the all evidence is not equal because the predictions they test are not equally certain and unique. Hence, authors should comment on the uniqueness and certitude of their predictions. In other words, they need to talk. When I bring about their evidence about their things, they support it, and the testing that the evidence they use to test or validate, they need to show the strength of their evidence, the strength and how unique and how certain the test. They're using evidence as a kind of test, a claim as evidence as a kind of test, right? And therefore, the test is going to. You have to talk about how unique, how good is the evidence. How good is this? How is it unique? Does what it say, is it highly unique and highly not, or low uniqueness, highly certain or lack of certainty? In other words, this adds to this in this question, right? Authors should comment on the uniqueness and certainty of the prediction. Strong tests are preferred to weak tests, but tests can also be hyper strong or unfair to the theory, right? That's the other thing. This is hyper strong or unfair. For example, one can perform tests under conditions where countervailing forces are present that counteract the presented text. In other words, tests can be set up that can be unfair. That you rig the test. In other words. For example, one can perform tests under conditions where countervailing forces are prevented that counteract the theory prediction. Passage of such a test is impressive because it shows the theory's cause has large importance, that is, high import, right? But a valid theory may flunk such tests because a countervailing factor masks its action. In other words, the test fails because this other factor masks its action. Such a test misleads by recording a false negative. Unless the investigator, mindful of the test's bias, gives the theory bonus points for extra hardship in the faces of this, right? And this is the problem. You have to understand. This is why when we use polling data, we have to look at, we're using polling data to understand things. This is why polling data has these what we call plus minus by things. We have these sampling error scale, error sample, errors. It's possible. It can deviate plus or minus these many points based on the precision of the sample size and these things. Even the biases that are in there. Some maybe that 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 this is going to bias. This will lead. In other words, we need to weight our findings to make it. No, if we know that it biases certain things, to make it that more accurate, we add pluses or minuses to different things in order to make it more reflect, knowing that this test is oversampling or over biasing a certain group, right? This is why we have these understandings. Look at how how the sample, what is the sample size, who's the test thing, how does that reflect the overall population, and then you have to scale things back in order to make sure you have to basically balance this out, right? We have to always understand the mindful of the test bias, given the theories. But that's why he said, given another form of hyper a strong test evaluates theories under circumstances that lack the antecedent conditions they require to operate. In other words, hyper strong test ignores it doesn't really understand under conditions that don't have the antecedent conditions they require to operate. Again, the theory is unlikely to pass, and we are impressed if it does. Right? It does pass. Right? Passage suggests that the theory has wider explanatory value than previously held. Right? Such tests are not fair measures of a theory's basic validity, however, since they assess it against claims that it does not make. Right? Advocates of testing theories against likely least sorry advocates of testing theories against least likely cases that ought to invalidate theories, any if any case can be expected to do so, recommends a hyper-strong test of this sort if the case they recommend is least likely because it lacks conditions needed for the test to operate. A flunk test then tells us that the theory will not operate if the antecedent conditions are absent. But it tells us nothing about the theory's validity when these conditions are met. Such tests are useful and appropriate if the scope of a theory's application is the main question. In other words, what is the scope of this theory? If that is the question, these tests are valid. But if they're not, they are inappropriate if the validity of the theory is questioned at the issue, right? And he says discussion of least likely cases in Eccleston's page right there. So we have this least likely case analysis, we argue. Why? Because we use it as a mechanism of testing, what he says here, exactly what he says here. He says, testing whether the antecedent condition operates or not. So if it is about testing the scope of the theory's validity, yes, it's valid. But if it's it's inappropriate for testing the validity of the theory itself. It's useful to understanding the scope of the theory's application, but not for the validity. So that's why this question is important to understand. Now we go back over here again, and deal with helpful hints of testing theories. Testing, and this is going to be, I think there's 10 of them, if I remember correctly. Let's look. If I remember my test, 9, 10, right? 10. 10, yes, 10 of them. The 10 helpful hints. Theory testers should follow these injunctions or warnings, right? These 10 warnings, right? Okay. 1, test as many of a theory's hypothesis as possible. So every theory is going to have many implicit hypotheses. Sometimes there's one hypothesis, but even that there's going to be implied and hypotheses that are connected or tied inherently into the theory. Testing only a subset of a theory's hypothesis is bad practice because it leaves a theory partially tested. A theory is filled. A theory is fully tested by testing all of its parts, right? You understand this? In other words, each one of these has parts, right? Here's the theory's parts. We should test not only a part, we should test the whole part. This part, and this part. So therefore you understand the connection of this to this. That's one aspect of test. This to this, this to this, this to this. In other words, these are the circles of all the different tests, right? The number of test hypotheses exceeds the number of links in a theory. Consider the theory A to Q to Q. A causes Q, causes R, causes B. Right? A completes the A complete A complete test would evaluate the theory's prime hypothesis, A causes B, the theory's exponential hypothesis, A, Q, Q, R, and RQ, and the hybrid combinations, R, A to R, and Q to B. Thus, thus a three-linked theory comprises of 6 testable hypotheses. And analysis should explore them all in time, if time and energy permits. So therefore, given this thing, you test all 6 possible hypotheses, and you test them all to make sure that they all validate. In other words, that they all come up valid. Okay. 2. Infer and test as many predictions of each hypothesis as possible. Most hypotheses make several testable predictions. So don't be quickly content to rest with one. So therefore, you have a hypothesis. Well, there's several different ways to test it. Engage and test them in different ways. To find more, tests. Consider what variance the hypothesis predicts across time and space. That is, across regions, groups, institutions, and individuals. Consider also what decision process, if any, it predicts, and what specific individual speech and action it predicts. Okay, in other words, look at it and think of the different things it predicts, and then test it in that situation. This and this. Look at both in terms of, like he says, in terms of across region, groups, institutions, individuals, right? Time and space. But also consider also what decision process, if any, what specific speech or action it would predict. Okay? And therefore you test every possible link, multiple hypotheses that are in each hypothesis has different tests, right? Predictions frame observations you expect to make if the theory is valid. In other words, the predictions you make frame what the observations you'd expect in the phenomena expect to make if the theory is valid. They define expectations about the indices, sequence, and location and structure of phenomena, right? So therefore, they define the expectations of the indices what is there, what are they, the sequence, location, and structure, right? Avoid framing tautological. That means A equals A. A equals A, right? That's tautology. Avoid framing tautological predictions that forecast simply that we expect to observe, things that we simply going to be, that we know that's cause, right? What we expect to observe. In other words, avoid framing tautological predictions that forecast simply what we expect to observe in the theory's observation. If the theory is valid, I predict we will observe its cause causing its effect. Okay, that's obvious, right? Okay, right? No, that is a tautology. It's something is valid because we know that it's valid because it's valid. No. A equals A. Thus, the hypothesis that democracy causes peace yields the following tautological predictions. We should observe democracy causing peace. A non-tautological prediction would be we should observe that democratic states are involved in fewer wars than authoritarian states. Okay, that's how we have thing. That's a plausibility, right? The tautology is that, okay, we should observe democracy causing peace. Well, that's a tautology, okay? What is the relationship to that? So we should see a pattern, right? How do we see a pattern? Okay. Therefore, we should observe that democratic states are involved in fewer wars than authoritarian. That's a strong group test, right? 3, explain and defend the predictions you infer from your theory. Okay. Explain and defend your predictions. As I noted earlier, scientific controversies often stem from disputes over which predictions can be fairly inferred from theory and which cannot be. When we see scientists agree on data but differ over the interpretations because they disagree on what the tested theories predict, right? Theorists can minimize such disputes by fully explaining and defending their predictions. In other words, if you explain and defend your predictions, then you have that little dispute about what the theory. They agree on the data, but they don't agree on the interpretation of the data, right? Because they disagree on what the theories, what the tested theories did predict. So you explain and defend your prediction. Predictions can be either general, the theorist predicts a broad pattern, or specific. A theory predicts a discrete facts or other single observations, right? The specific, general, broad patterns. Specific is a discrete, or in other words, specific and discrete means a single, like specific fact, and single observations, right? General predictions are inferred from and are used to test general hypotheses, right? So the general hypothesis, general prediction. If windows of opportunities and vulnerable drive states to war, states in relative decline launch more than their share of wars, right? So therefore, general predictions are inferred from and test the what? The general hypothesis, right? Specific predictions are inferred from and are used to test both general hypotheses. If the window of opportunity and vulnerability drive states to war, we should see Japan behave more aggressively as a window of opportunity opened in its favor in 1941, and specific explanations. So not only general, in other words, generals can only explain generals. Specific can infer both general hypotheses but also specific explanations. If the window of opportunity if a window of opportunity drove Japan to war in 1994, we should find records of Japan decision makers citing a closing window as a reason for war. Right? So. Therefore, there's a specific explanation, a specific prediction is testing not only general but also a specific explanation. They laid the explanation. 4, select data as accurately as possible. The domain, select data that represents as accurately as possible the domain of the test, what the test is actually going to be dealing with. Right? This is very important. Right? When using large n scale test methods, select data that represents the universe defined by test hypothesis. So the data must, in other words, the data must really represent the universe defined by this hypothesis, right? When using case studies methods, select data that represents the conditions in the case studies, right? So therefore, in large N, we look at select data that represents the universe that is defined by the hypothesis. In case methods, select data that represents the conditions in this case that is being studied. Even data that represents the domain of the test only crudely can be useful. This is Mearsham's, right? Assessing conventional balance, right? Rules for and illustrates the use of rule of thumb tests using data not selected for its representatives, right? This is Mearsheimer's point, right? That even things are not things, even they're not that represents, even data that represents a domain of the test only crudely, right, can be useful in that sense. Still, the more accurate representation, the better. Choosing evidence selectively, that is, favoring evidence that supports your hypothesis, overly disconfirming counter evidence is disallowed, since such a practice violates the principle of accurate representation. So therefore, you can't. Choosing your evidence, favoring one type. That's cherry picking, right? This is what you told us, cherry picking, or you eliminate evidence that disfavors your point, or add collect only evidence that support your hypothesis. It violates the principle of accurate representation, right? And that should, this is bad science. This is unethical. This is unethical behavior in that sense. And that's why, in fact, that's why using such bad cheats, this is a fallacy. In other words, fallacious reasoning to do that, cherry picking, and therefore that's why this rule is almost a platitude. But older political science literature, I'm thinking of the works in international relations, often broke it by arguing by example. In other words, this was an example. I think of broke it by arguing by example. Examples are useful to illustrate deductive theories, but only become evidence if they represent, even crudely, a complete relevant database, or that they're presented in enough detail to compromise a single case studies. So again, give an example. Arguing by example. Well, no, examples, again, this is an example has to be what? It has to be, maybe it's going to be relevant. It has to be what? It's not sufficient. It's not a single case. It is a single case. A single case does not prove the general case. So it's invalid in regarding the large N studies. One case cannot make a general rule, right? You cannot generalize from an N of one, okay? Only in an N of one. You can't generalize. In an N of more than one, you cannot generalize taking one thing and generalizing from that. You have to have a sample of this, a representative sample of it in order to do that, right? That's the idea. But one case is not necessarily representative of the case. How representative is the case you're using and generalizing from is to that the evidence is that one case, right? This is no. You should, in other words, only is that illustrate deductive. In other words, examples are used to illustrate deductive theories. Okay, so examples to use are useful to illustrate deductive theories, but use only. Sorry, blah 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 blah. Broke it by arguing, for example. Examples are useful to illustrate deductive theories, but only become evidence if they represent, and even crudely, the complete relevant database. In other words, or they present in enough detail to comprise a single case. In other words, the evidence a case can only become if they have enough detail to compromise a case study. Right. In other words, they have to it's going to be very rare that they're going to be represent the whole base data. So it's very unlikely that one case is going to reflect everything. Okay, so that one evident bit is purely accurately representative of every case. Okay, all the case, majority of the cases. Likewise, it can be used as if it has to be what? It has to be, in other words, you can use in deductive theories, but to become evidence if they represent, even crudely, the complete relevant database. Or they only become evidence that they are what? They represent the complete database. This evidence example can only be useful if this example represents the whole you're looking at. If it doesn't, that's why generalizing from a single case is not useful. It's problematic in that sense, right? Because it's unlikely that that's the case, right? Very unlikely. And the other thing is that they are present enough detail that this can be the case study. Okay, that's the only thing. That evidence is that this is so much detail that you allow to do. You're going to study this. You're going to study the relationship here. We'll see if here, right? 5. Consider and evaluate the possibilities that an observed relationship between two variables is not causal, but results from the effect of a third variable. Right. This is a discussion. This is that. In other words, these observed effects are not. In other words, consider and evaluate the possibilities that these things you're doing is not causal, but there's another variable causal. Two variables may convey because one causes the other, or because a third variable causes both. For example, in other words, convey means correlation. They're happening at the same time. They're happening there. Well, these things may have a correlation because why some other thing is causing them. Both of these things. So what you have to do is you have to disprove that this other thing is that nothing else is that nothing is causing these, and therefore, if a third variable causes these things, two variables may convey because one causes the other, or because the a third variable causes both. So this causes that, and that causes that. If that's the case, ooh. So you test it, and if this causes that, in other words, and this is we do this we cross compare, and we do this. We see which has this greater significance. If they have the identical thing, their outcomes are perfectly identical, or there's identical in this, then that's okay. That's something going on. They are not saying anything. But if one case there's a clear, stronger influence than the other case, each one is like this, and you have one. You do the analysis, and you see that one has a stronger effect than the other one has a weaker effect. Then probably the stronger effect is the causing one. Okay, more probable that's the causing one in that sense, right? And therefore, if they're the same, then they're probably okay. We can dismiss it. That maybe there is something else at stake. Something else. That's one way to do it. And the second is, or a third available, right? A third variable doing it, right? Two variables may convey because one causes the other, or because a third variable causes both, right? For example, the monthly sales of mittens and snow blowers correlate closely in the northern United States, but neither causes the other, right? In other words, that neither this and mittens and snow blowers, mittens don't cause snow blowers don't cause mittens, so therefore there must be a third effect, right? But neither causes the other. Instead, winter weather causes both. We should consider or introduce controls on the effect of such third variables before including what that correlation between variables indicate causation between them. So just because something has causation, we need to test, is there something else that could be causing both of these? And even if there is no thing causing it, maybe what of these two things, which is the causing, which is the one that is actually causing something to happen? And the one with the more powerful relation usually is the causing one. The effect with the most power usually is the one that's the causing. And if both are identical, then you can't tell, and therefore they're probably, one causes the other, and the other one causes the same effect on each other. That is indicating that probably that we can't validate causality, right? Okay, number 6. When interpreting results, judge each theory on its own merits, right? If you're interpreting results, judge each theory on its own merits. If you flunk or pass a theory, do not assume a priori that the same verdict applies to similar theories. Each theory in a theory family, such as neoclassical family of economic theories, the Marxist family of the theories of imperialism, the realist families of theories of international relations, and so on, should be judged on its own. The strengths and weakness of other theories in the family should not be ascribed to it unless both theories are variants of the same more general theory, and your test has refuted or collaborated that general theory. So therefore, if you've tested or validated that general theory, then these theories are part of that bigger theory, and therefore that if you failed this, but if you failed this, you can't necessarily fail other theories. In other words, you have to fail you have to fail the root before you can fail this particular. Okay, other. You failed this, but does that mean this will fail? Right? It doesn't automatically prove that. You have to test that. If you prove that, then you disprove that. But just because we disprove does not automatically disprove this, right? Your test has refuted or corroborated the general theory. If you flunk or pass one hypothesis in a multi-hypothesis theory, this says nothing about the validity of the other hypothesis in that theory. Some may be false and others true. You should test each separately. Okay. Consider that if just because one fails doesn't mean all fail. You have to test. You have to test each hypothesis. You should test each separately. Considering whether you can repair flunk tests before disregarding them. Flunk theories often contain valid hypotheses. Perhaps they can be salvaged and incorporated into a new theory. In other words, there's a valid hypothesis there that you just have to correctly define what you're doing with, so you can repair them. So consider repairing your flunk theory before you disregard them. 7, we can repair theories by replacing disconfirmed hypothesis with new explanatory hypothesis, proposing a different intervening causal process, or by narrowing the scope of the theory's claims. So we either propose a different intervening causal process, or narrow the scope of the theory's claim. We narrow a theory's claim by adding new antecedent conditions, conditional variables or CVs, right? So the theory no longer claims to govern the cases comprised in the flunk test. This allows us to set aside flunk tests. The theory is now more modest, but passes the test. So in other words, we become a more modest theory. We don't make a bigger. In other words, we become more modest, but it passes, right? 8, we can test theories against the null hypothesis. Right? We can test the theory against the null hypothesis. The test asks, does this theory have any explanatory value? Or against such other tests, or against, sorry. The test asks, does this theory have any explanatory value? Or against each other, the test asks, does this theory have more or less explanatory power than competing theories? 43. Emir Lacos likewise distinguishes a two-cornered fight between theory and experiment, the three-cornered fight between rival theories and experiment. His two-cornered fights are tested against the null hypothesis and his hypothesis the hypothesis of no causal relationship. His three-cornered fight includes a test against the null hypothesis and a theory against theory test, right? And this is Lacos' falsification and methodology in social science research programs, right? Works formatted in two-cornered tests include many studies on democratic peace theory, for instance, right? Chan, and he gives the example of two styles, right? So therefore, this is like, first of all, two-cornered test is what? Test that a null hypothesis and test against null hypothesis. And then the test between, the three-corner test includes what a test. So the null the normal test and the null hypothesis. Here, null hypothesis and a theory against theory test, right? That's three-corner test, right? So both test formats are useful, but they should not be confused. But they should not be confused. Theories that pass all their tests against the null should not be named. Theories that passed all tests against the null hypothesis, right, should not be named the leading theory without further investigation, right? They can still lose contests against competing theories. Conversely, theories that lose contests against competing competitors should not be dismissed altogether. They may still have some explanatory power. Theories with explanatory power are valuable even if other theories have more. So just because something has more power doesn't mean that this is no longer valuable. This is that this theory has more power, but this has less, but this is still maybe valuable in some cases, right? Number 9, One tests a theory by asking if the empirical evidence confirms the theory's prediction, not by asking how many cases the theory can explain. Okay, in other words, we don't we test the theory. Does we test the theory by asking if the evidence confirms the theory prediction, not by asking how many cases it explains. A theory may explain few cases because its causal phenomena are rare or because it requires special hothouse conditions to operate. But it can still operate strongly when these conditions are present. Such a theory explains few cases, but it's nevertheless valid. So, in other words, just because we ask a theory whether the empirical evidence confirms the theory prediction or not how many, the question of this. The number of cases of a theory, number of cases a theory is explained does shed light on its utility, right? The question of its utility. The more cases the theory explains, the more useful the theory, other things being equal, right? Still, even theories that explain very few cases are valuable if these cases are important and the theory explains them well. So again, just because they don't all do a lot of cases, but if this is an important case, not a lot of cases, but this thing is very important and it explains it well, even if it doesn't explain lots of cases. This is a very interesting. 9 is a very important point here. He says, interesting. Do not judge assumptions. Right. This is the down here point. Okay, sorry. Number 10. This is the last point. One does not test a theory by assessing the validity of its assumptions. We don't test the assumptions, right? We assume values of the CV. We don't test assumptions. We don't attest, do not attest assumptions. Assumptions, you test predictions, okay? A test asks, does the theory operate if the conditions that it claims to require for the operation are present? Framed this way, a test axiomatically assumes assumptions are true. Tests under conditions that violate the theory's assumptions are unfair, and theories should not be rejected because they flunk such tests. In other words, if you, in other words, that this theory assumes that these things being so, this should happen. Well, if if you test it to saying, well, this is not so, then therefore that means your theory is wrong. No, that's an unfair test, right? A test axiomatically assumes that this is true, right? Tests under conditions that violate the theory's assumptions are unfair. And theory should not be rejected because they flunk such a test, an unfair test. The validity of a theory's assumption does affect its utility, however, right? So that question, in other words, if something's rare, in other words, assumptions that never give, assumptions that never hold give rise to theories operating in only an imaginary world and cannot explain real reality or generate policy prescriptions, right? This is a but. And it was very rare like this, right? Assumptions that never hold. It may be true, but it's an imaginary world, right? 44. For a different view, see Friedman. In general, the more significant the theory, the more unrealistic the assumptions. Friedman's claim stems from his exclusive focus on the ability of theories to adequately predict outcomes, the values of the dependent variable. He is uninterested in the validity of the inner workings of the theories, including the explanation as well as their assumption. This unconcern is appropriate if knowledge uh, about the nature of theories' inner working is not useful, but it's seldom the case in the study of politics. In other words, it might be true in some of an abstract theory, right? But in politics, in other words, the nature of the inner workings is not useful, but that is useful for politics. For politics, the nature of the inner workings is sometimes the heart of key of the political action, right? So that, but the most useful theories are those whose assumptions match reality in at least some important cases. So therefore, the most useful theories. So therefore, we shouldn't dismiss it, right? If the question is unfair and the assumptions are unfair, but the assumptions are just so impossible in that they're not reflect reality. They need to reflect the assumptions must reflect reality. They don't reflect reality because the most useful theories are those theories whose assumptions match reality in at least some important cases, right? So therefore, they must match some important ways. Well, that ends our discussion of theories testing. We'll finish up this. This was I spent I think an hour on this. I hope not, but we'll see what I do. So take care. If you have any comments, questions, please put it below. If you want to see more of this, subscribe, share it with a friend, share this with us. If you want to see more of this, share it with a friend, subscribe, and get them to subscribe. If you liked it, again, hit the like button. Uh, share it in your social media. Share it on the things, and share it even again. Share it again. Share it with a friend. If you didn't like it, if you had something had objection or something, please give the comments. I don't like the writing on. I'm sorry, this is the best edition. The other one I had with no writing on it was kind of yeah. It was small and you couldn't see it, and even if it blew it up, it was even more unreadable. Um, so if you want to follow me below, you can follow me below. The links are below on social media, but also my academic social media about who I am and what I do. The other things are what else? The brain word. Um, oh yeah, you can if you want to help what I do here, you can do so by subscribing to our Patreon. Another thing you can do is you can buy one of my books that are listed below there too. Okay, and that's it. We'll stop. We're finishing up the chapter 1 in our next post, which will about wrap up this chapter, this first chapter of Evera, and we'll see you there. Take care. Bye bye. Have a good day.